Guys, before we start our stream, we'll first pray in the phones.
I don't wanna fight you, shadow. Meet me back in 5 doesn't matter to you. Like I say I do. So get up. I don't wanna fight your shadow. Maybe back in 5 doesn't matter to you. Like I say I do. Hi, it's me again, I'm back. Let's talk ASAP. Do you have the time? Let's talk ASAP, baby. Hurry up, don't be lazy. ASAP, baby. Hurry up, don't say maybe. 할 얘기 다 한 줄 알고 빨간색 눌러. 끊고 나니 생각나서 다시 또 울려. There's this one more thing I'll show you. Come with me, so much to do and lot to see. Just for a minute. Just for a minute. Hi, it's me again, I'm back. Hey, let's talk ASAP. Do you have the time? Let's talk ASAP, baby. Hurry up, don't be lazy. ASAP, baby. Hurry up, don't say maybe. ASAP, baby. Hurry up, don't say, hurry up, don't say. Just for a minute. Just for a minute. 정말 짜릿했어 어디선가 내게 운기한 까만 눈동자 But your beautiful eyes got me lost now Yeah yeah 깜짝 놀라게 하기는 해도 자신만 나는 너의 그 태도 Like you from the get-go 쿨함은 그대로 부담감은 제로 Cause you know you're sparkling like a shooting star I can see us going far 얼마나 성감할까 Little pop-up all around the world 마법 같은 Like you from the get-go 쿨함은 그대 I'm ready, let's go You already know Coca-Cola 마시다 Coca-Cola 마시다 See you looking catchy, here's a cola See you looking catchy, here's a cola Coca-Cola 마시다 Coca-Cola 마시다 See you looking catchy, here's a cola See you looking catchy, here's a cola
In this video, we're going to focus on how to simplify radicals, including radicals. In this video, we're going to focus on how to simplify radicals, including and when to multiply by the conjugate. So let's start with simplifying radicals. You need to know 8 squared is 64, 9 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144. We're going to go up to 20. 13 squared is 169, 14 squared is 196, 15 squared 225, 16 squared 256, 17 squared is 289, 18 squared is that's 321. Actually 324, excuse me. And 19 squared is 361. 20 squared is, I'm going to put it here, 400. So let's say if you want to simplify the square root of 8. Which of these perfect squares, which is the largest perfect square that goes into 8? It's 4. 8 divided by 4 is 2. So what you want to do is simplify root 8 as root 4 times root 2. And then you could take the square root of 4, which is 2. So your answer is 2 root 2. So let's try another example. Let's say if you want to simplify the square root of 18. Which number goes into 18? What's the highest perfect square that goes into 18? It's none other than 9. 18 divided by 9 is 2, so the square root of 18 is the square root of 9 times the square root of 2. And the square root of 9, we know it's 3. So this simplifies to 3 root 2. Now let's say if you want to simplify the square root of 50. 25 times 2 is 50, and 25 is a perfect square. So this simplifies to 5 root 2. So, for the sake of practice, go ahead and try these examples. Try the square root of 27, the square root of 48, the square root of 128, the square root of 450, and the square root of, let's see, of 27. Go ahead and try root 2. So, for the sake of practice, go ahead and try these examples. Try the square root of 27, or the square root of 48, the square root of 128, the square root of 450, and the square root of, let's see, 98. And of 1200. So feel free to pause the video and try these problems, and then unpause it when you're ready. So let's start with the first one. What perfect square goes into 27? We know 9 goes into 27. 9 times 3 is 27. And the square root of 9 is 3. So this simplifies to 3 root 3. Now what's the highest perfect square that goes into 48? 4 goes into 48, but the same is true for 16. So if you start with the highest perfect square, it's going to make simplifying it a lot easier, especially when you're dealing with larger numbers. 48 divided by 16 is 3. So the square root of 16 is 4. So this simplifies to 4 root 3. What perfect square goes into 128? 128 is 64 times 2, and the square root of 64 is 8. Now what about 450? this is 225 times 2. And the square root of 225 is 15. And for root 98, that's 49 times 2. And the square root of 49 is 7. Now what about 1200? What's the largest perfect square that goes into 1200? This would be 400. The square root of 400, well, 3 times 400 is 1200. And the square root of 400 is 20. So you get 20 root 3. So that's how you can simplify perfect squares, or radicals that have, let's say, an even index number. If you don't see a number here, there's an invisible 2. Now what about simplifying cube roots? So you need to know your perfect cubes. We're going to go over the perfect cubes at least up to 10. So 1 to the third is 1, 2 to the third is 8, 2 times 2 times 2 is 8, 3 cubed, or 3 times 3 times 3 is 27, 4 to the third power is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 to the third is 1000. 10 times 10 times 10 is 1000. So let's say if you want to find the cube root of 16. What is the highest perfect cube that goes into 16? Well, it's none other than 8. 16 divided by 8 is 2. So you want to rewrite cube root of 16 as the cube root of 8 times the cube root of 2. And the cube root of 8 is 2, because 2 to the third power is 8. So this simplifies to this answer. So go ahead and try these examples. The cube root of 54, the cube root of 192, and the cube root of 375. So 27 goes into 54, and 27 times 2 is 54. And the cube root of 27 is 3. So this is 3 cube root of 2. Now what number goes into 192? You can take each perfect cube and see which one is divisible by 192, and pick the largest of them. 8 goes into 192 and 64, but we're going to choose 64. 192 divided by 64 is 3. So when you split it, it's going to be 64 times 3. And the cube root of 64 is 4. So we get 4 cube root of 2.
Okay.
Here we have 375. Because there's a 5 in it, chances are it's divisible by 125. So 375 divided by 125 is 3. And the cube root of 125 is 5. Oh wait, this was supposed to be a 3. So that answer was supposed to be 4 cube root of 3. I don't know why I put 2. Maybe I got in the habit of writing 2's. Try these two. The cube root of 1024 and the cube root of 5000. So the largest perfect cube that goes into 1024 is 512. 512 is half of 1024. So we can rewrite this as 512 times 2. And the cube root of 512 is 8. So this simplifies to 8 cube root of 2. For this one, 5000 is 1000 times 5. And we know the cube root of 1000, that's 10. So we get 10 cube root of 5. Now the next thing you need to know is the fourth powers. Let's say 1 to the fourth is 1, 2 to the fourth is 16, 3 to the fourth is 81, 4 to the fourth power is 256, 5 to the fourth power is 625, and 6 to the fourth power is 1296. So let's say if we have these three problems, the fourth root of 32, and the fourth root of 162, and the fourth root of 768. So feel free to pause the video and try these practice problems. 162, so we have the fourth root of 81 times the fourth root of 2. And the fourth root of 81 is 3. So we get 3 times the fourth root of 2. Now which number goes into 768? Let's see, 768 divided by 81 is a decimal answer, so that doesn't work. 768 divided by 256 is 3. So we can rewrite this as the fourth root of 256 times the fourth root of 3. The fourth root of 256 is 4. And that's the answer we get for that problem. Now let's add some variables to the mix. Let's say if we want to simplify the square root of 50, well, before we use numbers, let's just keep it simple. How would you simplify the square root of x to the third? Now keep in mind there's a 2 here. One way you can do this is you can split it to the square root of x squared times the square root of x. The square root of x squared is just x times root x. Now depending on the level of depending on the algebra course that you're taking, some teachers will want you to put an absolute value. If you have an even like index number, and if you get an odd exponent, some teachers may want you to put it in an absolute value. Other teachers, they may not focus on that concept, but depending on the course you take, I'm going to add the absolute value, just so you know when to do so. So let's say if you have the square root of x to the 7th. Here's another way you can do it. How many times does 2 go into 7? 2 goes into 7 3 times, so it's going to be x cubed, and then with 1 remaining, x to the 1. Another way to show your work is you can separate it as x to the 6 times the square root of x. Here, this is a 2. 6 divided by 2, you can rewrite that as x 6 over 2, which is x to the 3rd times root x. But I'm going to stick to one method. So let's say if you want to find the square root of x to the 9. How many times does 2 go into 9? 2 goes into 9 4 times, with 1 remaining. So let's say if you have the cube root of x to the 13. How many times does 3 go into 13? 3 goes into 13 4 times, with 1 remaining. But this time you gotta put the 3. Let's say if you have the cube root of x to the 11. How many times does 3 go into 11? 3 goes into 11 3 times, because 3 times 9, 3 times 3 is 9. And the difference between 11 and 9 is 2. So 3 goes into 11 3 times, with 2 remaining. So using what you know, go ahead and try these practice problems. Find the square root of x to the 5th, the cube root of x to the 17th, the fourth root of x to the 15th, and the seventh root of x to the 19th. 5 minus 4 is 1, so the remainder is 1. Now how many times does 3 go into 17? 3 goes into 17 5 times. 3 times 5 is 15. 3 times 6 is 18, which
Nothing.
is too much. So
Dali man
it
lang.
goes into 17 5 times. And 17 minus 15 is 2, so we have 2 remaining. But we gotta write the 3 here as the index number. How many times does 4 go into 15? 4 goes into 15 3 times.
Ha? Basa? Ay, shit! Ato na? Sure, lagi na yun. Sipan mo. Yun lang mo. Pasang, ano,
Times. 4 times 3 is 12, and 15 minus 12 is 3. So the remainder is also 3. Now how many times does 7 go into 19? 7 goes into 19 2 times, because 2 times 7 is 14, and 19 minus 14 is 5. Do you see the pattern? That's the quick way to get the answer. But remember, if you want to show your work, let's focus on this one. What you could have done is, and it's so is as x, you get x squared, the variable inside. So now the root of x to the fifth. Everything together, cube y to the radicals, and then simplify it. A perfect square that goes into 50. Is 25. So 50, I'm going to write it as the square from the root of y. Added for some other examples, but if you want to add it here, collect it and put it inside. And then everything else that can't be simplified, collect it and put it inside a single radical. So the square root of 2xy. That's the answer for that example. So let's try another one. So let's say if you want to find the square root of 72 x to the fourth, y to the fifth, z to the sixth. A perfect perfect square that goes into 72 is 36. So we're going to write this as the square root of 36 times, write it as to the 4, leave it alone, x to the absolute value. The square root of y to the 4th is y squared, and the square root of z to the 6th is z to the 3rd. So we have an even index, an odd result, so we're going to put this in the absolute value. Then every other term that wasn't simplified, in this case the 2 and the y, we're going to put it inside the radical, so 2 times y. So that's the answer for that particular problem. So now let's try a cube root. So let's say if you want to simplify the cube root of 24 x to the 6, y to the 7th, z to the 10, r to the 13. So what perfect cube goes to 7 does times to 10 is times that. Now this one, 9, we get r to the 4th. Everything else is going to stay in the cube root. So we have a 3, we have a y, we have a z, and we have an r. And so this is the answer for that problem. So now let's try a 4th root. Let's say if we want to find the 4th root of 32, x to the 7, y to the 12, z to the 15, r to the 20. So what number goes into 32? That says the 4th 12. Let's go. Even going to put y to the 12 and the 4th. So we can put this whole thing in an absolute value. So everything else, we're just going to collect it now inside one radical. So we have a 2, we have x cubed, and we have z to the 3rd. And that's our answer. So now let's say if you get a problem that looks like this, 8 divided by radical 3, and you want to simplify it, what can you do? In a situation like this, all you can do is rationalize the denominator. So what you want to do is multiply top and bottom by the square root of 3. So you're going to get 8 root 3 divided by root 9. 3 times 3 is 9. But the square root of 9 is 3. So this is the answer that you get. So let's say if you have 5 square root x. What would you do? Multiply top and bottom by root x. So you're going to get 5 root x times x. And that's it for that one. So let's say if you have 7 divided by the cube root of 4. So this is like 4 to the first power. What would you do in such a situation? Now notice this is what you can't do. You don't want to multiply top and bottom by the cube root of 4. The reason being is on the bottom you'll get the cube root of 16, and you can't really get rid of the radical because 16 is not a perfect cube. You could simplify it, but you want to get rid of the radical. So instead, you want to do something different. You see, notice that there's a 3 here, but you only have 1 4 inside. You need 2 4s to have a total of 3 4s to get it out of the radical. So what you want to do is multiply top and bottom by the cube root of 4 squared. Because 4 to the first power times 4 squared is 4 cubed, which is 64. And the cube root of 64 is 4. So right now we have 7 times the cube root of, I guess in this part, 4 squared, we can write it as 16. And on the bottom we have the cube root of 4 to the third. We can make that 64, but we don't need to. The 3's will cancel, and the radical will disappear, so we'll just get 4 on the bottom. Now the cube root of 16, we can simplify that, because 8 is a perfect cube. So we can break it down as the cube root of 8 times the cube root of 2. And the cube root of 8 is 2. So we can replace it with times 2 cube root of 2. And 2 divided by 4, we can simplify it. If we divide it backwards, 4 divided by 2 is 2. So we'll put that 2 on the bottom. And so this is what you get. That's the simplified answer for that problem. So let's say if you have 9 divided by the 4th root of x to the first power. So what you want to do is multiply top and bottom by the 4th root of x cubed, because 1 plus 3 is 4. So you're going to get 9 4th root of x cubed divided by the 4th root of 1 plus 3 is 4, so x to the 4. So these will cancel, and then you'll get 9 4th root of x to the third over x. So that's how you can rationalize that denominator. So now let's say if we have this problem. 5 divided by the 7th root of x squared. We need to get up to 7, so 2 plus 5 is 7. So we're going to multiply by the 7th root of x to the 5th, top and bottom. So this is going to be your final answer. Well, not yet though, but initially we're going to get the 7th root of x to the 7. When those two numbers are the same, the radical disappears. And that's our answer. Try this one.
Ano ma? Okay ka po. Okay ka po. Ma'am, di man mga bulfin, ma'am.
Let's say if you have 3 divided by the ninth root of x squared, y to the 4th, z to the 7th.
Guess we're to cancel everything is nine. This is my theoretical. It's going to small super seven. You have to get boost. As you can do it's again. You can actually seven. Then
How would you rationalize the denominator in such a situation? So what you want to do is multiply top and bottom by the ninth root of something. Now, you want all of the exponents to add up to 9. 9 minus 2 is 7, so you need x to the 7. 9 minus 4 is 5, so you need y to the 5. 9 minus 7 is 2. So these are the values that you need. So you can get 3 times the ninth root of x to the 7, y to the 5th, z squared, divided by the ninth root of x to the 9, y to the 9, z to the 9. So all of the 9's will cancel. So this is 3 ninth root of x to the 7th, y to the 5th, z squared over xyz. So now you know how to rationalize denominators under any situation or circumstance that you might find yourself in. But what about this problem? Let's say if you get this problem like on a test or something, or in your homework assignment. What would you do to simplify it? If you see a radical separated by, like if there's a number and a radical separated by a plus or minus sign, multiply top and bottom by the conjugate of the denominator. So since we have 4 minus root 3, the conjugate is 4 plus root 3.
What is a conjugate? Conjugate is so we need to multiply by the whole plus
Change the minus to a plus. On the top, we're going to distribute the 15. 15 times 4 is 60, and
and
15 times root 3 is just 15 root 3. On the bottom, we're going to FOIL. 4 times 4 is 16. 4 times root 3 is 4 root 3. And 4 times negative root 3 is negative 4 root 3. And negative root 3 times root 3 is like negative square root 9, which is just negative 3. Because initially you get this. 3 times 3 is 9, and then the square root of 9 is 3. So you get negative 3. So notice that the two middle terms will always cancel every time you multiply by the conjugate. So what we now have is 60 plus 15 root 3 divided by 16 minus 3, which is 13. So that's how you simplify it.
vowel command it's gonna stay like 60 plus 15 root 3 divided by
16 minus 3, which is 13. So that's how you simplify it. So for the sake of practice, try this one. 10 divided by root 5 plus root 2.
found the one conjugate times root 5 times root 5 minus root 2. It's gonna be 50 minus 10 root 2 over square root of 25 minus 2. So this is 15 minus 10 squared 2 root 2 pala 5 minus over 3.
So what we need to do is multiply top and bottom by the radical, the conjugate of the bottom.
Oh,
So on the top, we're going to distribute the 10. So it's going to be 10 root 5 minus 10 root 2. On the bottom, we're going to FOIL. Root 5 times
Root 5 pala. Oh, okay lang. My bad. Forgot. 10 root 5 minus 10 root 2 over 3.
root 5 is just 5. Now we know the two middle terms will cancel, so we'll just multiply the last two. So root 2 times root 2 is just 2. It might be better to keep it in its factored form. We'll rewrite it like this. And then 5 minus 2 is 3. So that's our answer. Okay, try this one.
Wait, what? Okay.
2 times root 2 is just 2. It might be better to keep it in its factored form. We'll rewrite it like this.
Oh, right. Kay duwa man sila may harate, man na lang na items na lang.
And then 5 minus 2 is 3. So that's our answer. Okay, try this one. 3 minus root 2 divided by 5 plus root 2. So once again, and 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 on the bottom. So say if you have a goal 23.
What?
So if we FOIL the numerator, 3 times 5 is 15, and 3 times radical 2 is negative 3 radical 2. Here, 5 times root 2 is negative 5 root 2, and the two negative signs will cancel. Root 2 times root 2 is
It only
just 2.
works in conjugates. I see. So, bawal pala yung method na yun. Sige, let's try again. 15 minus 5 square root 2. Ayun.
So, and on 3 minus 5, is negative 8 root 2. And on the bottom, what we have is 23. So that's our answer for that problem. So next, we're going to go over adding and subtracting radicals. So let's say if you have a problem that looks like this. 3 square root of 18 minus 4 root 50 minus 5 root 32. How would you simplify it? So first, let's break down the radicals into perfect squares. Radical 9 is 20, and the square and something we add variables. The negative square root 1 is negative 31. So it's negative 31. 11. The square root is going to remain the same. The square root of 9 is 3. And the square root of 25 is 5. And the square root of 16 is 4. So 3 times 3 is 9, square root 2. And 4 times 5 is 20 times the square root of 2. And 5 times 4 is also 20, square root 2. So at this point, we can add the x. units. This situation is similar to, let's say if you have like 9x plus 5x. You add 9 plus 5, you get 14, and you keep the variable the same. Imagine the square root as an x. When you add the coefficients, the square root is going to remain the same. So 9 minus 20 is negative 11, and negative 11 minus 20 is negative 31. So it's negative 31 square root 2. Let's try another example like this, but one involving cube roots. So let's say if you have 12 times the cube root of 16 minus 2 times the cube root of 54 plus 5 times the cube root of 128.
One, 8, 7, 64.
Eight is 7 12 times 12.
Hmm.
So next, we're going to go over
Like, fuck what? Yeah.
like how to multiply radicals. So let's say if you have the square root of 5 times the square root of 6. This is just the square root of 30. And we can't reduce the square root of 30 because there's no perfect square except 1 that goes into square root of 30. So that's all we can do for that problem. But now let's say if you have this one, the square root of 12 times the square root of 32. How would you do this problem without a calculator? that could be like 300 or 400,
Mm.
and you're going to have to simplify that large number. Or you can make your life easier and simplify it before you multiply it. What perfect square goes into 12? 4. So
4
break
and
down the
3.
square root of 12 as 4 times 3. And what perfect square goes into 32? 6. I mean, not 6, but 16. 32 is 16 times 2. And then now you want to simplify it. The square root of 4 is 2, and the square root of 16 is 4. So now what you want to do is multiply the 2 and the 4, the numbers on the outside. That's going to give you 8, times the numbers that are inside the radical. 2 times 3 is 6. And this is your answer. It's a much
Shibal. Hmm.
easier if you simplify
Mhm.
first before you multiply. So let's try another example. Let's say if you want to simplify or multiply 5 root 20 by 7 root 18. So don't multiply 20 by 18 yet. Simplify it first. So a perfect square that goes into 20 is 4. So 4 times 5 is 20. 20. And a perfect square that goes into 18 is 9, and those 0. And 5 and 2 is square root of 3 over 5 times the square root of 5 over 7. How would you simplify it? So you could just multiply across. We can't really simplify 3 and 5. They're not perfect squares. So we can combine this into a single radical. What we have is 3 times 5 divided by 5 times 7. We can cancel the 5's. 5 divided by 5 is 1. So our final answer is just, well, right now we have the square root of 3 over 7, which is the same as root 3 divided by root 7. Now, most teachers, they want you to rationalize it. So we're going to multiply the top and bottom by the square root of 7. So we're going to get root 21 over 7. And that's our answer. So let's continue.
I'm gonna take a short break, guys, because when that's tired, I'll just take a 30 break. So yeah, uh, I'll just check first if my stream was a success. Is a success. Right here. Uh, and
How would you rationalize the denominator? Y to the 4th, z to the 7th. Reduce the square root of 30 because there's no perfect square except. How would you rationalize the denominator?
okay na. I'll rest for a bit, guys. Sige, see you. See you, see you.
You definitely are to go in. They're so awesome. And listen to Discord and TH. It's really good. And obviously they are a girl band, which is like unheard of in Korea, which is amazing. And yeah, honestly, they're amazing. She listens to songs because they basically dominating the mellow charts. So
Shit! Fuck! Sayang! Kikipe! Wanna count shoulders? Wanna count shoulders? I'm good, shawty. Good, shawty. What? Shawty, guess who? Guess who? Guess who? Guess who? It's my whole gang. Sa amin yung West Philippine Sea kasi mag-good boy man kami doon. Hindi man kami mag-fight, mag-swimming na lang man kami doon. Mag-puti man ako doon. China, ibigay na sa amin yung West Philippine Sea kasi mag-good boy man kami doon. Hindi man kami mag-fight, mag-swimming na lang man kami doon. Mag-puti China, ibigay niyo na lang sa amin yung West Philippine Sea kasi mag-good boy man kami doon. Hindi man kami mag-fight, mag-swimming na lang man kami doon. Magputi man ako doon. China, ibigay niyo na lang sa amin yung West Philippine Sea kasi... What? Flint? Coal. So happy. I know. What? Flint? Coal. I know. What? Flint? Coal. She's so happy. I know. What? Hello?
Ilang nag-deliver ng siomay?
Why?
Why pa siomay nag-abot?
Wala man sa doorbell?
So, why mo to?
Check ko.
Business lang. Parents, get the fuck out of here. Parents, get the fuck out of here. Why did you just say that again, Des? I didn't. I did not say that. What? I swear to God, I didn't. Parents, get the fuck out of here. Dude, why is it doing that? I did not say that. No, that's every. No one's fucking with me. Parents, get the fuck out of here. How the fuck? I'm doing that.
You're finding a little this.
Cool? No. Well, I'm gonna do it anyway. Yo, you wanna see something cool? No. Well, I'm gonna do it anyway.
Just trying to play cool, but I just piped that I want you. Just trying to play cool, but I just piped that I want you. You guys enjoy the performances? Yeah? 여러분, 그거 아세요? 아리랑, 아리랑, 아리랑. 아리랑도 우리 국가유산으로 지정되어 있다고 해요. 아리랑뿐만 아니라 명절이면 온 가족이 함께 보고 즐겼던 씨름과 윷놀이, 그리고 전 세계인이 좋아하는 음식 한식도 우리의 국가유산이라고 합니다. Not only arirang, but also our holiday favorites, shirim and yunori, are our esteemed heritage. And let's not forget, Korean cuisine is another precious national Pretty guys. No, pretty. Take Rose is pretty.
It's not even a rose.
Take Rose.
It's not a rose.
It's pretty.
Sorry, it's
Take the rose.
Sorry.
It's pretty. It's pretty, look.
Sorry, no. I don't want to be. Sorry.
He's pretty.
Okay. Thank you.
Yes.
Thank you. I have the money, so.
No money.
Sorry.
No
Stop the money! I don't have no money! Stop the money!
Quite a long, paparating na sa susunod na estasyon ay Stop calling the police! Paparating na sa Cubao!
Malapit na ako mag-toxic pa. What music should we play? What about Smarter from the Seraphim? Oh yeah, I love that song. That song by that girlfriend with Chill. I can explain. How do you know Smarter from the Seraphim? I just saw them while scrolling on TikTok. They were dancing. Oh, you watched the dance video, yeah? You dance? Did I say dance? You dance in that video? Oh, I was talking about lyrics. Like, I know the instrumental. I know the things. They dance? Boy, show me your TikTok likes. The thing is, I deleted TikTok because of my exams. Just show me. Man, is that the island?
Okay guys, tara. Study.
So let's say if you have this problem. The square root of 8 divided by 27 times the square root of 30 divided by 12.
Alright, we have these. Wait, where's the divide again? Where did I divide, man? Where's the division? Division. So we have 8 over 27 times the square root of 30 over 12. So I think I can simplify 30 and 12. Yeah. This is gonna be 8 times 30 over 27 times 12. So I need to find a way to cancel something. Maybe I'll do 4 times 4 times 30. Then 27 times 4 times 3. So I've canceled out the 4. Now it's left me with 4 times 30 over 27 times 3. Okay, now let's see, what can I do here? So 27. I really want to cancel something. So 27. So this divisible by 3. So 30 is 4 times 10 over, we divided by 3, 9 times 3. Then we've got 40 over 27.
So, instead of multiplying by 8 and 30, let's simplify. Let's see what we can cancel. So, 30.
I got 27 here, so of course 27 is gonna be denominator. That's 40 times 27. It's just 270 times 4. So basically 8, 10. So 1080. So pwede pa yan ma-simplify over 9. So 9, 3. So 1080 divided by 9. This is 1, 9, 180, 120. Pwede pa rin ma-simplify again. So definitely 1, then 20, 120 over 3, that is 40. And so the answer is 40. 40, right?
The top team, square root of 5.
What the fuck? Wait, how am I wrong? Wait, how am I wrong, bro? 40 over 27. How am I wrong? Oh, I'm confused. Wait, what is the value of 2 square root 15 over 9? 2 root 15 over 9. Wait lang. Sige, wait lang, guys. I have to go to the bathroom muna. So, see you guys. Wait lang, wait.
4 times 2.
I already forget. So square root of 8 over 27 times square root of 30 over 12. This is 8 times 30 over 7 times 12. First thing I noticed is that I could reduce the 30 and 12. They're both divisible by 2. So you can have it as 15 and 6. Yes, 15 and 6. Which you can also divide. This is 5 over 2. So ayan, 8 times 5 over 2 times 27. Siguro 27 times 2, just gonna is 14 or 54. 54 over, I don't know, 40. It's gonna give us 4 over 7.
27, we can break that down to 3 times 3 is 15, and 3 times 2 times 3.
So, hindi pa rin siya nag-work out. So, once again, let's try again. And 4 times 4 times 5 times 2 times 3 over 3 times 3 times 3 times 4 times 3. 4, 4, 3, 3. So we're left with 4, 5, 2, 3, 3, 3.
Great. So 4 times the square root of
Oops, I messed up. I see. And then so it's 20 over 27. Which is 20 over square root of 27. 27, 27. So 27
5, because 20 divided by 4 is 5. As we can see here, these 2's, they make the 4, and here's the remaining 5. And a perfect square that
16.
that goes into 27 is 9. 20 2 we have times. So our final answer is 2 root 15 divided by 9. So now let's say if you have a problem that just looks like this. The square root of 25 divided by the square root of 36. What's the answer? For this one, simplify it one step at a time. The square root of 25 is 5, and the square root of 36 is 6. And that's all you got to do for that one.
Number 6.
Now what about this one? The square root of 200 divided by 12. So before we try to like 100 is you can divide now. Now what about this one? You get 5 root 6 divided by 3. and that's the answer for that one. Now what about this example? The square root of 40 over 55. First. That's perfect square. And on the bottom we have the square root of 2. Try this example. The square root of 18 x to the 7 y squared divided by 48 x to the 3rd y to the 5th. For exponent. So 24 6 root 6y over 12y squared.
Wait, bakit dala pa yung 6y?
Actually, we could reduce that. 12 divided. So our final example for this video is y. Okay, now
Hindi, mali ka pare. Because I have learned yesterday na kung saan daw mas malaki, dun daw pupunta yung ano, yung bale yung ang tawag dito, yung variable, dun siya pupunta sa pinakamalaking ano, pinakamalaking digit. So I don't believe na nasa numerator yung 6y. Dapat na siya denominator siya. Mali yung pag-solve mo. Ayokong tanggapin na tama yung sagot mo. Because I've learned something yesterday about this. Ito talaga yung pinuna kong review eh. Tapos nalaman ko na, ay wait, mali pala yung pagkakasulat ko. So we have 18 x to the 7, y squared 88x cubed y gets ko na. Mali ako. Nakalimutan ko i-rationalize. My bad. Yan. Tama naman, tama naman. Ay, what the fuck? Ba't y squared, ha? Kala ko ba i-rationalize? Walang yo.
So we have y to the third on the bottom. And we still have the square root. Now, those two smallest square roots is the same as if I wrote a largest square root down into 4 times 6 square root. And which we're going to multiply top and bottom by 3x squared root 6y. On the bottom, we have 2y times 6y.
Yeah, 2y times 6y. Oo nga, 6y. May natitira pa pala. Yan nga.
So our final answer
Ay, tanga ko pala. 2 times 6 is... 2 times 6 is 6? No, it's 12, dames. Kaya pala.
is 3x squared root 6y over 12y squared. So this video is going to be this problem. Okay, now that's
Yeah, okay na, okay na. Tanga ko pala mag-multiply. Okay na, okay na.
the final answer. So our final example for this video is going to be this problem. The square root of 75 times x to the 8 y cubed over 108 x squared y to the 7th.
Alright, let's solve this. So, I know na pag pinas mo to 12, tas 9. So, hindi siya divisible by... Mga ngayon. Ang tawag doon? Alang, yeah. How to get 75? We can get... So, sa 75, we can do... So, 70. So, let's make it 70. Can make it... No. 75 over 5 ba? It's 1, 2, 5, 2, 5, 15. So, 15 times 2. Square root of 15 times square root of 2. Tama na, 15 times 5. Tanga. 15 times 5. Tapos, 108 naman. We got 554. We got 54 times 2. We have 54. Pwede pa na yan. 54 over 2, 2, 4, 14, 27. 27 times 2. Now 27 is just 3 times 3 times 3. And so that's what we have. Okay, now what can we cancel? Nothing. We can't cancel anything. Oh, 15. We can cancel some from 15. 5 times 3 to eh. And 5 times 3. So, wala na yung isang 3, 3. So, kalalabasan yan, may 5 times 5 over ito. 3 times 3 times 2 times 2. Yan. 25. Ay, 25 na yan. 25. No, squared pa rin sila. New jeans, please. Let me show.
사실 궁금했어 저기 산다 내 눈에 띄던 까만 내 글자 Boy stylish glow up got me hooked now Yeah yeah 살짝 뒤늦게 보이긴 해도 완전 달달한 너의 그 애교 Like it from the get-go 스윗함만 그대로 불안감은 제로 Cause you know it's sparkling like a shooting star You can see it's going far 얼마나 상큼할까 We will pop up all around the world 마법 같은 걸 I'm ready, let's go. You already know. Coca-Cola 맛있다. Coca-Cola 맛있다. See you looking catch it, here's your cola. See you looking catch it, here's your cola. Coca-Cola 맛있다. Coca-Cola 맛있다. See you looking catch it, here's your cola. See you looking catch it, here's your cola. 이 노래는 it's about you, baby. Only you. You. 내가 힘들 때, 울 것 같을 때, 기운도 이제 나지 않을 때. It's you. 날 걱정하니, it's you. 어렵게 하니, 말은 해도 돼, but what do you say? 멀리든 언제든지 달려와. 바쁜 척도 없이 난 나타나. 이게 말이 되니 난 물어봐. 너는 말야, it's don't just living in the system, baby. Oh my God, yes I'm that. I was really hoping that it will come through. Oh my God, 전 너뿐이야. Asking all the time about what I should do. No, I can never let him go.
Actually, there's only one other thing I want to mention. Let's say if you have the square root of a negative number. Now, this is not a real solution. This is an imaginary solution. You can write this as the square root of 4 times the square root of negative 1. The square root of 4 is 2, and the square root of negative 1 is I. So let's say if you have the square root of negative 8. A perfect square that goes into 8 is 4. So you have 4 times 2 times the square root of negative 1. The square root of 4 is 2, and the square root of negative 1 is I. So you get that answer. So now I believe we've covered every topic relating to radicals. You know how to add and subtract radicals. You know how to multiply and divide radicals. You know how to simplify. You know how to rationalize. And if you see any negative numbers inside, you don't get a real solution, but you could write it as an imaginary solution. Just keep in mind, I is the square root of negative 1. I squared is negative 1. I cubed is negative I, and I to the 4th is 1. If that
So I is the square root of negative 1. I squared is negative 1. I to the I cubed negative I. Then I to the 4th is 1.
becomes relevant sometime in the future. There's actually another example that I almost forgot to go over, but is pretty relevant to this video. So let's say if you have the cube root of x to the 7, and you wish to multiply it by the 5th root of x to the 3rd.
Yes. Medyo, I think I have quite some knowledge about this.
How would you
Just fifth root, diba? And then magiging 15 yan. Tas, just times them. 10.
do it? Now, let's say if you have the square root of 5, and if you want to multiply it by the square root of 6. 5 times 6 is 30. And it seems pretty straightforward. But the only reason why we can do that is because the index number is the same. So let's say if you want to multiply the square root of x cubed times x to the 5th. X cubed times x to the 5th is x to the 8. You just got to add the exponents. And that reduces to x to the 4th. Only because the index numbers are the same are we allowed to multiply by what's inside. But in this scenario, the index numbers are different. So we can't just say x to the 7 times x cubed and write x to the 10. Because what index number would you write? 3, 4, 5, or something else? So then how do we simplify a problem like this when the index numbers are different? What do we do? What you need to do is convert it from its radical form to its exponential third, 5. And this number becomes the numerator. And this number
Okay. So kung ganyan, cube root of x to the 7 times fifth root of x to the 10. Gagawin lang daw, tas yung exponent gagawin exponent yan, tas yung root dyan. Tas ito times mo. Okay.
number becomes the denominator.
Mm.
Now, when you multiply two variables, let's say like x squared times x cubed, what you have to do is add the exponents. 2 plus 3 is 5. So here we have the same base, which is x. So to multiply these two variables, we have to add 7 over 3 plus 3 over 5.
10 over 3 plus 3 over 5, so we have 35 plus 9 is 44.
And the only way to do that is to get common denominators. This is x.
Sige, mas maganda na lang kung gagamit ng LCD. Times by 5, so 5.
And the only way to do that is to get common denominators. So I'm going to multiply this side by 3 over 3 and the other fraction by 5 over 5. So what we now have is 35 over 15 plus 9 over 15. So this is x 35 over 15 times x 9 over 15. Now that we have the same denominator, we can add the numerators. 9 plus 35 is 44. So this is x raised to the 44 over 15. Now you want to simplify it. How many times does 15 go into 44?
Dalawa lang.
15 goes into 44 two times. 30 is 30 is divisible by 15. So I'm going to write 44 over 15 as 30 over 15 times 14 over 15, because 30 plus 14 is 44. 30 divided by 15 is 2. And the last one, we can't simplify it, so we can rewrite it as the 15th root of x to the 14th. Now another way you could solve this problem is, at this point you can convert it back to radical form, which is the 15th root of x to the 44. And then simplify it using the techniques that we've covered in this video. How many times does 15 go into 44?
Oh, goods yan. Mas mabuti yan.
It goes
Okay, so 6, 44, 15. So, 6, x, 44. And so, we have x squared over x.
into it 2 times. 15 times 2 is 30, but 15 times 3 is 45, which exceeds 44. So 44 minus 30 is 14, and you end up getting the same answer. So let's try another example. So let's say if you have the 5th root of x to the 4th, and you wish to multiply it by the cube root of x to the 8.
Okay, so, let's go. The 5th root of x to the 4th times the cube root of x to the 8th. So, it's gonna be x 4 over 5 multiplied by x over 3. So we have 4 over 5 plus 8 over 3. This is 15. We got 12 plus 14. So we got 42 over 15. So we got x is 42 over 15. We make this again as a radical. So this is 42, this is 15. The answer is x squared x 42 minus 15. That is, I know, tama. 12, 27. I know not 15. 42 minus 30 is 12.
Using what you know, feel free to pause the video and give this problem a shot.
I gave it a shot
15,
now.
53 is 2. So this, let's
Wait, the fuck?
variable.
I'm a dumbass. Why am I such a dumbass? I forgot. 12 plus 40 is 52, not 42. So, again. 4, 5 plus 8 over 3. I'm all about speed math kasi. So, we got 12, 40. So, this is 52. And we got x 52 over 15. So, it is x 52 root of 15. So, here we have x to the third x 52 minus 45 is 4 12 7 root 15. Ayan. So I got the answer. Goods.
Variables remaining. So this is our answer.
Yep.
So let's say if we have a number instead of a variable.
Ayan. Goods.
Let's say if we wish to multiply the cube root of 16 times the square root of 12.
So we got the cube root of 16 times the cube root of 12. So it's gonna be 16 and 1/3 times 12 times 1/2. So just this is 6 over 2. 2 plus 3, 5 over 6. So we got x 5 over 6 equals x square root of 5, 6. Yeah, that's the answer.
The cube root of and 4. And he base 4 times 1, which square can only if the change be so basically.
Why is it taking so long?
Now
What the fuck? What the fuck?
20.
Why is it so long?
The cube root of 16 is the same as the cube root of 8 times the cube root of 2. And
Wait again. 16 minus 1. 12. No.
so what we now have is the fourth one, which square can only multiply the bases. The for example, now let's say if we had this problem. Let's say that somewhere let's say we can have this one. The cube root of 8 times the cube root of 2. And the cube root of 12, the square root of 12 is the square root of 4 times the square root of 3. We could simplify these two because the cube root of 8 is a perfect cube, that's 2, and the square root of 4 is also 2. So what we really need to combine is these. The cube root of 2 times the square root of 3. So 2 3, but we not to. So let's say, but you can't say 4 squared times 5 cubed is 20 because what exponent would you have? So that doesn't work. But let's say if you have 4 squared times 5 squared, that's equal to 20 squared. So to now have is, so we can only multiply the bases if the exponents are the same. So for example, let's say if you have 4 times 5 is 20. Can't say doesn't equal to the 4 cubed exponents. So right now the bases are different. So to combine the 2 and 3, we got to make the exponents, we have to get similar exponents. So let's see if that's possible. Actually, that's not possible. There's no way we can get the same exponents for this problem. Let's say if you were to get common denominators, this would be 2 over 6, and the other one would be 3 over 6. 2 over 6 is the same as 1/3. 3 over 6 is 1/2. So because let's say if you have 2 and 2 over 6 times 3 and 3 over 6, neither the exponents or the bases are identical. So we can't combine that. So our final answer is just 4 cube root of 2 times the square root of 3. We can't combine those. Now, let's say if we had this problem. The cube root of 2 times the square root of 2. Now, let's say if we had this problem. The cube root of 2 times the square root of 2. This we can combine 2 only if the bases are the same. To the 5 over 6, which is the 6th root of 2 to the 5, or 2 to the 5th power. So only if the bases are the same can we multiply two radicals over a different index. So try this one. The cube root of 4 times the 5th root of 4. Times over 4, we get 4 to the 8th power. We have the 15 root of 2 squared. We can actually simplify further because 4 is equal to 2 squared. So we have the 15 root of 2 squared raised to the 8th power. Now, when you raise one exponent to another exponent, you need to multiply it. So 2 times 8 is 16. So this becomes the 15th root of 2 to the 16. And so this becomes the 15th root of 2 to the 16. And 15 does go into 16 at least once.
Going to be uh,
So 1, 2 comes out, and the remainder is 1. So we get 2 times the 15th root of 2. That's the final answer for that problem.
let's see.
Now what about if we're dividing two radicals with a different index? So let's say if you have the 4th root of x to the 9 divided by the cube root of x squared.
Object of x to the 9 followed by cube root of x squared. Simplify muna. This is x. This can't be possible. Ay, never mind. This is
How would you do this one? So first, let's convert it to exponential form. So now we need to get the common the exponents. 27 minus 8, and the 12 can put that. So how many times is 12 going to? Seven rather than root of x to the 7. Common denominator between 4 and 3 is 12. So this is going to be 3 times 9 is 27.
There we go. Okay. Finally got it.
Now, what about this one? The cube root of 32 divided by the fourth root of 32.
Steam. Okay, so that makes it easier. Have 8 cube root of 8 times 4. Then we got maybe 4th root of 2 times square 4th root of 2. So now it's going to be 2 to the 2 cube root of 4, and then I 2 cube 4th root of 2 cancel out. Two squared 2 to the 4th.
Raised to the 4. 12 minus 3 over 12 is 1 over 2. Different index number.
Oh, ang isang lang. Ay, sinabi ko, ako ba? Sorry.
So now you know how to simplify radicals, especially if there's different index numbers. You know how to multiply or divide radicals with different index numbers. But by the way, make sure you understand that you can't really add or subtract radicals with different index numbers. like the cube root of 2 plus the fourth root of 2. You can't simplify them if they're separated by addition or subtraction. 2 to the 1/3 plus 2 to the 1/4. There's nothing you can really do here. It's like saying x cubed plus x to the 4th. You can't add them. You just leave them the way they are. So you can only simplify radicals with different index numbers if you're dealing with multiplication or division, not addition and subtraction. So that covers this video, and thanks for watching, and have a great day.
Right. Oh, that was long. After away ko na. Tapos ko na radical expression. Hey guys. So we're done with radical expressions. I have to test myself later to see if I really understand what I already understood what I just watched. Yeah, so maybe later I'll do 20 item quiz, then I'll record it and upload it in YouTube, my video. So yeah, say guys, thank you for watching. Please subscribe. See you again.